Yeah.
All right, problem 7 on the worksheet. This is going to lead us into what we are going to do today, so watch carefully. This will help a whole bunch as far as learning what we're going to do today. I don't expect that you knew how to do number 7. Now, I do expect that as we go through and we do it, you could have done down so far, and then like the last step, you shouldn't be able to do because that's what we're going to learn today. Give me just a minute I'm going to draw the picture up here, if it lets me. Yeah, this is number 7, sorry. Boy, my picture looks exactly like theirs, doesn't it? Is that an E out there at the end? You have to help me, especially stupid different colors. I can't see nothing anymore. They say write a paragraph. It says it's do what? Oh, okay. So you guys are ahead of me. It says write a paragraph proof. I don't know. I thought I erased that on there. I want a 2-column proof, of course. We're not going to bother with paragraph proofs a whole lot. First thing I'm going to do before I start to do all that extra stuff that you guys are telling me, I'm going to split the 2 triangles off. That's D, E, G there. Some of you may be a little better than me, but I can't look at the triangles as they're together. Confuses me.
I think it's easier because I can see like what sides are like.
So see, that's different minds think different ways. So if it helps you to do this, now the only problem with that is sometimes we'll do, I don't remember if there was any on here or not, but you might do something like this. They might give you a picture, it looks like that, and there's like 10 triangles in the picture, and maybe they want you to prove that this triangle here that I'm tracing in red is congruent to this triangle. Then that gets real confusing. So then I would think it's probably a whole lot easier to split them off.
Prove that those 2 are congruent.
I know, don't. You're getting ready to make fun of my drawing.
No, I wasn't. I was saying.
I know it's a new week, Peyton, but you can remember that my drawing's not good. All right, so the first thing that they give us that angle D is congruent to angle F, so we'll mark that. D is congruent to F. I'm just going to write given. That's a pair of angles, right? So we know we have one pair of angles. Remember, we're trying to get to side, 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 angle, side, angle, side, angle, or angle, angle, side, one of those. Well, we have a pair of angles right now. Which one do we know we're probably not going to use? So let's just get rid of that. We're probably not going to use that since we already have a pair of angles. GE, that's this coming down through there, bisects angle DEF, which is this angle. Well, what's it do to that angle if it bisects it? Splits it into 2 equal angles or 2 congruent angles. So name this top angle for me. Angle what? Can we just name it angle E? You got to name it with how many letters? 3 letters. Remember that. Remember, you're just the top angle, so it's this angle right here. So what's the name of it again? Somebody name that angle for me. DEG. Good. Angle DEG. And we know it's congruent to which other angle? GEF or FEG. With angles, it doesn't matter if you match them up correctly or not. So we started here with DEG. It doesn't matter if we go FEG. You can name it the other way. With the triangles, it matters. All right, but with the angles, it doesn't make any difference. So whichever of those 2 ways you name it would be fine. How'd you know that those 2 angles were congruent? what's the key word there in that given statement? Bisect. So I'm just gonna, remember this is our rough draft, so I'm just gonna write bisects down there, just to remind us when we get to our formal or 2-column proof.
Wouldn't you know that GE would be the same for this angle?
You're always a step ahead of me. Give me a second, all right? You gotta let me do my spiel. I feel like I'm useless if you're ahead of me. What do we know now? What up here are we not gonna use? Let's get rid of that. Now, Peyton, now we gotta come up with something on our own, right? And what is it? All right, GE. I'm running out of space down here. Segment GE is congruent to segment GE. And Peyton's telling us that's the reflexive property. That's a pair of sides. Should have been marking all these as I went. We had those two angles were congruent. Those two angles were congruent. Now we have this side is congruent to this side. Is that enough to say the two triangles are congruent? Yeah. By which postulate or theorem? Angle, angle. Which one is it? Now here's where you got to make sure you don't get confused. It's angle, angle, side, because the side's not the included angle, right? It's not the one between the two angles. So it goes angle, angle, side. If it was this angle and this angle congruent, then it'd go angle, side, angle. It'd go in the right order. So we know the triangles are congruent. And our reason there is going to be angle, angle, side. And I know that's not what we're trying to prove. What we are trying to prove is that segment DG, let's see, that's right here. That segment is congruent to segment FG, which is right there. But once you know these two triangles are congruent, what do you think has to be true about those two sides? They have to be congruent. And I'm going to give you a reason for that when we get down to it on this 2-column proof. Statements, reasons. What's our first statement going to be?
D equals F angle D.
Angle D is congruent to angle F. How'd you know that? That was a pair of angles, so I'm just going to put a little A out here to help me. Now, if you wanted to, I guess we do have that order. It doesn't matter. These little letters seem, I always use them. If you don't want to use them because it confuses you as to what you're actually using to prove the two triangles, then don't, because they don't have to go in the correct order in your 2-column proof. They just have to be in the right order in your diagram. Okay? So if those confuse you, then don't use it. Where are we going to go to next? Over here at our rough draft. Now, do we want to jump right to here? And this is part of the rough draft that confuses people. Can we just jump right to those two angles being congruent? What do we need to know before that? How do we know that this angle was congruent to that angle? Something about bisecting, right? So that was the given. So we need that given in there. This is part where Josh is always telling me, well, I don't need to say all that. I already knew that. Well, he knew it. He knew it, but whoever's looking at this next, did they know it? So you need to tell them, hey, we were given this information, and it led us to this. So it bisects angle DEF. Can you read that? How do we know that ray GE bisected angle DEF? It was given to us. Can I put a little S or A out here beside this? There wasn't a pair of sides or angles in our two triangles, right? So it tells us something, but it doesn't lead us directly to what we need to prove the two triangles. What did this lead us to? If that bisects that angle, now we knew what? what is it, DEG and FEG?
Yeah. Not right, much talk. There's-
Now again, here's where a lot of you have trouble. You have to write a reason. If you have to write out a reason, and it's not like the reflexive property or something easy like that, it's going to be an if and then statement. If this, then this. And where the if's going to come from, that's up here. That's the statement right before it. Okay? What was the key idea in this statement? Bisect. So my if part's going to be if, and maybe I'll even be a little better this time. If angle bisected, sounds like I'm a caveman or something, I know, but it's good enough. If angle bisected, then what? Then fire. Then what?
Makes two equal.
The angles.
Alright. Then split, oops, then, yes, two congruent angles. That's not written very well. That was a pair of angles, so I put an A out here. Is that enough to say the two triangles are congruent? How many parts do we need?
Three.
We need 3 parts, we need 1 more. Where'd that come from? What sides? GE is congruent to segment GE is congruent to segment GE. How do we know that? Reflexive property. What's reflexive property say again?
It's equal to itself.
Anything equals itself. Anything equals itself. Remember, with reflexive property, before I go on to the rest of this, 3 things that you're going to use throughout this chapter to help you with these proofs. That you should be able to, you look at the diagram before you ever start the problem and think, hey, I'm going to use reflexive property somewhere in here. All right? That's one of them, reflexive property. These are all things that you should just be able to look at the diagram and see right away. Anybody remember any others that you should be able to look at a diagram and see right away?
Vertical angle.
Vertical angles, good. And then the other one is if you have parallel lines. So if you have parallel lines,
Transversal.
then you should think of alternate interior angles, right? Because we're going to use them a bunch. Those are 3 things that you got to just see right away. Once we have this out here, do we now have enough to say the 2 triangles are congruent?
Yes.
Yeah. So the triangle, somebody name this top triangle for me. Easiest question of the day.
DEG.
D-E-G, I heard G. Now Josh wants to name it G-E-D, can he do that? You just have to make sure you match them up. What do you have to do to this triangle to get it to match up to this one?
Name it the same way.
Flip it, right? Flip it, all right? Just reflect it. So what's the D going to match up to? F. So triangle F. What's the E match up to? E. And what's the G match up to? How do we know that those 2 triangles were congruent? Angle, angle, side. Please remember, and I think you guys do.
Now on the test, will we be able to write AAS or
Yep.
that's right?
No, just write it out like that. Some of these, the ones that you have to write out, like when you have a bisector, midpoint, something like that, just that shortened part. And then we'll get to other things like, we'll get to isosceles triangles, and you'll have to write, it'll say triangle ABC is isosceles. And then you'll have to know that segment AB is equal to segment AC because it's isosceles, and you'll put, if isosceles triangle, then 2 legs are congruent. So some of them you'll have to write out like this. Reflexive property, these things, no reason to. Now, that's not what we were trying to prove, though. What were we trying to prove in this picture?
DG is equal to FG.
This segment DG is congruent to segment FG. That's what I'm going to write right here. DG is congruent to segment FG. Now this, I said you couldn't do all this, but If I collected this as soon as you walked through the door, should you have been able to do steps 1 through 5? Yeah. Step 6, should you have been able to do the statement? Yeah, you just couldn't do the reason probably. Now, most of you are probably intelligent enough that you could have gave me some kind of reason. Well, since I know these two triangles are congruent, I know that these two sides have to also be congruent, and you could have probably written that out. But I'm going to give you another shortened form of something that you can write in here. That's your reason. That's your reason. And what we're going to talk about today is we're going to talk about what that reason means. Say that word for me, Weston. All right, what it stands for, corresponding. Does everybody know what corresponding means?
No.
Ones that match up. So when we flip this over, certain things matched up, right? Corresponding parts are like the sides and the angles of a triangle, of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. All right? All you got to remember is, hey, if we prove these two triangles are congruent, what do you know about all the parts that match up? They're congruent. And if you remember, every other letter here is a C. Starts with a C, ends with a C, has a C in the middle, P and T in there. I don't care that you remember exactly what CPCTC stands for. You will by the end of the chapter probably, because it's not that difficult. But just remember that, hey, once I know the two triangles are congruent, then all the matched up parts have to be the same. Now, when we're doing this, when you're doing two-column proof, some of the things, you know that some just key ideas, usually the first 1 or 2 statements given, right? The triangles, what do you know about number 5, the reason
It
over
has
here?
to be one of those.
It has to be one of those 4 things right there. Can't be anything else. All right? Once you prove the two triangles are congruent, step 5 here, or whatever step it happens to be in your two-column proof, guess what the next reason is going to be 99.99% of the time? CPCTC. All right? So if you're writing a two-column proof, and you're going down through there, you probably know this one's given. Maybe number 2, the reason's given also. You could just about fill these in without doing anything else. Triangles are probably going to be right here. We know it's one of those 4 things: side, 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 angle, side, angle, side, angle, 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 side. It has to be one of those 4. And then what I know this reason is going to be. So I haven't even given you a problem yet. You could probably get 1, 2, maybe you get lucky and guess 3, 4 points out of the 14 points there, and we don't even have a problem or diagram or anything to start with. And you got 4 out of 14 points. All right? It's always going to be that way. Usually the given. Now, all the given doesn't always have to go right at the beginning. You know, you could have it given way down here somewhere, depending on when you needed it. But we know this has to go with the triangles, and we know right after you use one of those 4 things, the next reason is probably going to be CPCTC. Now, I say that probably. Most everything that we do, it will be. Maybe Brighton goes out and he's some kind of NASA engineer or something. Well, it might. Maybe as he's writing up a paper or something to prove something, he's Sheldon off of the
Big Bang Theory.
Big Bang Theory, couldn't think of it. He's Sheldon and he's trying to write a paper to prove it. Well, that doesn't have to come next and everything, but in here probably will. All right, next question. Number 5. Number 5. That's the same picture, isn't it?
No.
Yeah.
It's the
It's
same.
different letters, the same picture.
So do we have to?
Number 5. Number 5, if you look at that now, is that sort of the same thing as what we just got done doing?
Yeah.
Except at the end, instead of proving, I erased it up here, after you prove the triangles, instead of proving two sides are congruent, what are you going to prove?
Angles.
2 angles are congruent. Now, I'm even going to go a step farther and show you something on this one. My other classes, a lot of them I probably won't bother with this because I don't know that they would catch on anyway. Just confuse them more, I'm afraid. So we have that picture. I'll split my 2 triangles off again. Mostly just to bother pace. That's the wrong picture. All right, what do they tell us? Let's start giving information this time.
Angle X is congruent to angle U.
So that angle's congruent to that angle. What else do they tell us?
TR bisect.
Which angle does it bisect?
STU.
STU. So same idea down here. What do we know about these 2 angles then? They're congruent. Those 2 angles are congruent. Now, if we were trying to prove these 2 triangles were congruent, where would we go to next? Same thing as the last one. Maybe a side. Which side? RT is congruent to RT because of reflexive property. That's enough. Angle side again to prove the 2 triangles are congruent. And then we could say the other pair of angles are congruent. On this one, we actually don't need to do that. There's a shorter way to do this. We had a theorem right before Christmas break, that said if these 2 angles are congruent, these 2 angles are congruent. What do you know about these 2 angles?
Yeah.
They have to be congruent.
Which means the side.
Now, we're trying to prove those 2 angles, SRT and URT. We're trying to prove that they are congruent. Do we have to prove the triangles are congruent first? We know that these 2 angles are congruent, these 2 angles are congruent, so that tells us that these 2 angles have to be congruent.
That's what I thought, but there's nothing that says angle.
Right, because you don't have to prove what?
The triangle.
You don't have to prove the triangles. So what we're going to do here, if my board would ever quit switching. I'm watching you, Emma.
It is your witch.
What we're going to do on this one, first statement, angle S is congruent to angle U. Is it all right for them to name angle S and angle U with 1 letter? Can you name that angle with 1 letter? How about that one? Yeah. How about that angle? That angle? So they took the easy way out and named the only 2 angles in the picture you could name with 1 letter. That was given. Statement 2 is going to be that ray TR bisects angle URT, or no, STU. And that was given. Once we know this ray bisects this angle, what's that tell us? What's that tell us about those 2 angles?
They're equal.
They're equal. So somebody name this top angle for me.
STR.
STR, so angle S. TR is congruent to, what's the other angle?
UTR.
UTR. Very good. How do we know that?
Bisector.
Okay, if what?
Bisect,
If angles bisected,
then next to
then I'll write this one a little better. Split into two congruent angles. Now again, we know this angle congruent to this angle. We know this angle is congruent to that angle. Instead of going through all the process of proving the two triangles are congruent, what do we know about these two angles? They have to be congruent to each other. If this angle, let's say this angle right here was 50 degrees, well then we know this angle down here is 50 degrees. This angle was 30 degrees, we know this angle is 30 degrees. Well, if that angle's 50 and that angle's 30, what's angle TRS have to be right here? 100. And what's angle TRU have to be? 100. Well, what do we know about those two then? They're congruent to each other. So we actually don't have to go through all the extra 2 or 3 steps and prove the triangles, then say, all right, CPCTC, corresponding parts of those congruent triangles are congruent, because we can use another theorem that we had earlier this year. So what is the proof statement this time? What's it say? Angle what?
STR.
Say it again.
STR. SRT.
It's congruent to what?
Or
And the reason for that, this is a theorem that we had right before break. If two angles of a triangle are congruent to, I'm trying to think of the shortest possible way to write it, two angles of another triangle, then third pair of angles are congruent. I know there's a shorter way to write that, but I couldn't think of it right at the moment. So on that one, we didn't even have to go through. Now, could you have went through and proved that the two triangles were congruent, and then said that this angle is congruent to this angle by CPCTC? Yeah, it took you about 3 or 4 extra steps. Probably been 6 steps or 7 steps, I don't know. So sometimes you got to watch out. Sometimes they'll throw something like that in. You're thinking, you know, you're stuck on, yeah, I got to prove the triangles, then I got to do this, then I got to do this. And you go through all that and you think, well, I didn't have to do all that. All I needed was to go to this point. That's sort of what this one did. Other questions? Everybody got that before I erase it? Yes, no, maybe?
Hey, don't judge. You think I am baby?
Today is the, what? Today is the 12th? 13th? 12th to 13th, one of the two.
13.
Why did they give them back to you?
Because you were closer.
Today's the 13th. Go ahead and start copying this down. The title, CPCTC. We'll run through this pretty quick, especially since we already did that one problem. Same stuff we were doing before. We're just adding a step to it. All right, CPCTC. We're going to use CPCTC with congruent triangles. Please remember, it's always used after you prove two triangles congruent. It can never, ever, ever be used anywhere in a proof before you've proven two triangles. So if you're doing a 2-column proof and your first statement is whatever it is, and your first reason you write down CP, CTC, it's wrong. Because you have to prove the triangle's congruent before you can ever use this as a reason. Alright? So the only place it can come is after, like we said on that other one, after you've proven the two triangles are congruent. That's what CPCTC stands for. Go ahead and write that down. Corresponding parts of congruent triangles are congruent. So you have your C, P, C, T, C. What's that called? An anagram? Is that what it's called when you abbreviate something just by the first letters? It's not an anagram. Apparently, Josh should know if he's supposed to be a senior in English, right? What's that called when you...
I'm too tired.
No, excuse me, Josh.
I'm sure it's anagrams, isn't it?
Anagram is a word they spell backwards.
Yeah.
Oh, it's an anagram.
That's a palindrome.
That's a palindrome.
Yeah. No, anagrams are the ones that you can look at.
Hey, I'm not even gonna respond.
Yeah, because my first one is one cut, two on the back.
Really? I didn't know there was a special name for a word that you could look at upside down.
Yeah, it's a word for a beer.
I think it's anagram, I'm not sure. So corresponding parts of congruent triangles are congruent. So you got these two triangles. If you look at the two triangles, you can sort of tell in this case which two they are. I'm still going to split them off. Maybe I won't split them off this time because I don't have much room. Yeah, we'll just leave them that way. They tell us that, what's that symbol mean? Parallel. So GH is parallel to KJ. Soon as you see that you have parallel lines, again, I want you to think of alternate interior angles. What do you know about alternate interior angles? They have to be congruent. So as soon as you see that, alternate interior angles. Well, if these two lines are parallel, do we have any alternate interior angles?
Yes.
Let me change my pointer color here so that I can... I can't do blue. We'll do red just for a second. If this parallel line, what can you use as the transversal? GJ. And if I do that, use that as our transversal, what do they form right there? A Z. And what do we know about those two angles? They're alternate interiors, so they have to be congruent to each other. Somebody name this top angle for me so we can write it over here in our rough draft. Angle H. That's my pen here. H, G. All right, that's one. HGJ, and it's congruent to which angle? Name this other angle for me. KJG. That's a pair of angles. They were alternate interior. I'll just write alternate down there just to refresh our memory. Now you also, if we trace that, we could use GK as a transversal and say that this angle and this whole angle up here are same side, or I'm sorry, consecutive interior. That's not going to do us any good, because what do you know about consecutive interior angles? Instead of being congruent, they're supplementary. They add up to 180. So that doesn't really help us, and that's why most of the time you use an alternate interior. Every now and then you might have corresponding angles, but alternate interior is the one you're going to use the most. They tell us that second given, GK, is parallel to HJ. So this one parallel to this one. Can you see those green lines? Now again, we have this one line, this is the other line. We could use this as the transversal Do we have other alternate interior angles? What did those green lines form together? A Z or an N again. So what do you know about these two angles? They are same, they're congruent. Somebody name this angle for me. JKG. No, say it again. And somebody name this angle for me.
PJH.
Have to listen closely with G's and J's. Again, that was alternate interior. Just right there. That's a pair of angles. Is that enough to say the two triangles are congruent? What else do we need?
You can put a side,
What side?
GJ,
What do you know about GJ?
there was one side.
Oh, yeah.
It's congruent to GJ. Now Josh is saying, oh yeah, if you split those two triangles apart, is that a little easier to see that they share that side probably? Yeah, maybe.
See, I find it easier when they're together.
Because I looked up
The
what,
exact same thing.
Yeah, whichever way it's easiest for you. So we now know that this segment's congruent to itself. So how can you tell me that this triangle is congruent to that triangle? What do you got to do to it? Say it. Go ahead.
Angle, angle, side.
Is it angle side?
Angle, side, angle.
Angle.
Which one is it?
Angle, side, angle.
Angle side.
Angle.
Oops. Angle side angle, right? All right. What do you got to do to these two triangles to get them to match up? Can you just flip it over? It's got to rotate around, doesn't it? But we should be able to say the two triangles, and that's what we're trying to prove. So now we should be able to do our two-column proof. Something up around here. What's our first statement going to be? First given. GH, segment GH is parallel to segment KJ. That was given. Can I put an S out here beside that? A lot of people do this and mess up. Can you put an S out there beside that?
No.
Because you're not saying that they're congruent, you're just saying that they are parallel. Yes. Yes. Do I have Brittany? Yes. Sure. Once you knew those two were parallel, that led us to what pair of angles? Was it the red ones or the green ones?
Green.
Green? Red?
Come on, Emma.
It was the red ones, right? So.
Emma.
Right, why do you do that?
Austin's meeting.
Angle HGJ is congruent to angle KJG. And our reason for that,
Oh, that wouldn't be a reason.
sort of, you're going to say, remember you say the if, so if lines parallel, and you're probably going to use this one over and over and over again this whole chapter. So if lines parallel, then alternate interior angles congruent. As a matter of fact, we're going to use it again in the same proof. That was a pair of angles, so I can put a little A out here beside it. Where are we going to go to next? Okay, we could do the side. If you wanted to do the side next, you could go right ahead. If you wanted to go to the other given, that's what I'm going to do. It doesn't matter really. Either way, just make sure you don't forget that you have that other given. Knowing that these two green sides here were parallel, what angles did that tell us? And our reason there, same thing as we had up there on number 2. If parallel lines, keeps confusing me because it pops up 3 seconds after I write it. If parallel lines, then alternate interior angles are congruent. It's another pair of angles. Now where do we go to? And what were our 2 sides? GJ is congruent to GJ. Good. How do we know that? Reflexive property. While I'm writing it down, what's reflexive property say again? Anything is equal to itself. Do we now have enough to say the 2 triangles are congruent?
Yes.
So, and they've actually already named them for us. So do we have to match them up ourselves? If they've already got it, then let's just write it down the way they got it, make it easy on ourselves. Triangle GJK is congruent to triangle JGH. How do we know that those 2 triangles were congruent?
Angle side.
Which one was that?
Angle side angle.
Make sure you look back at the picture, because you don't want to do all this work and then miss that last step just because you put it in the wrong order. Which one is it this time? Angle side angle. Angle side angle and angle angle side is the only 2 that you should be able to really mix up. Now again, what we're going to go on to today is, once you know that this triangle is congruent to that triangle, what can you tell me about this angle right here and this angle up here? They're congruent to each other because of CP/CTC. What can you tell me about this side GK and this side HJ? They're congruent because of CP/CTC. So we could, if it would ask us to go a step farther, we could put another step on there and you guys don't want to write all these down, do you? We'll do one more. Let's see. What I have up for 6 and 7. Let's see.
7's one of those ones where you're talking
7.
Man, you put none on here with CP/CTC in it. I don't know why. Let's write. We'll do 7, but we'll change it. EGD.
What was that?
KHD. Let's do 7, but we'll change it around. So write this down once I get it written down. Angle E is congruent to angle K. Somebody's looking at their book, and if I write something down wrong, please tell me, because I keep looking at the wrong problem. DGH is congruent to angle DHG. And segment EG is congruent to segment KH. We're trying to prove, and I'm going to change the prove from what it says in the book. Let's see, EG is congruent to that. Let's go with, we're trying to prove that segment ED is congruent to segment KD. So I'll give you a second, write that down. I guess I should draw the picture. While I'm drawing this with the seating chart, is there anybody that sits in the back that can't see that would rather be, anytime that I make up a new seating chart, please tell me if you sit in the back and you have bad eyes, because I know I couldn't sit in the back.
Yeah, just go ahead and cross it out.
on Thursday.
Just tell me and I'll find you a better seat, a more appropriate seat. Also, I think I said something last time about some extra credit work. I will start putting extra credit up there. This worksheet, as you walk out today, if you wanted to do it, I'll count it as extra credit.
1, 2, 3, 4, 5, like 6.
There's at least 6. All right, so do you know which ones for sure that you're going to need to prove congruent? Probably not, so it may be a little harder to split off. So what we probably want to do is go through here and mark some stuff. Angle E, congruent to angle K. Angle D, H, G, that's this angle, is congruent to angle DGH. It's this angle. I said them backwards, but that doesn't matter. And then segment EG is congruent to HK, so those two are congruent. Now we got to figure out which triangles, and what we're trying to prove is this segment is congruent to that one. We got to figure out which triangles we actually want to try to prove are congruent. Which ones do you think? DEG and DKH, that one? So just the outside two? All right, that might work. The only bad thing about that is those two angles aren't in those two triangles, are they? But
they're alternate, like,
if these two angles are congruent to each other, what do you know about these two angles? They're supplementary. What do you know about these two? Supplementary. And didn't we have a theorem earlier this year that said if two angles are supplementary to the same angles or congruent angles, then those two angles have to be congruent. So we can end up saying that those two angles are congruent.
So wait, wouldn't it just be easier if we do DHE and then...
So this big triangle here, and this one here. Now that would be all right also, and you could do it that way, except are these two segments in that triangle, or in those triangles? No, but we also had this earlier this year. You have GH here. What could we do if I'm looking at this? We got E here. We got G here. Now we don't know for sure it's a midpoint, but what's this look like? What postulate? Segment addition. You could add GH to this segment, add GH to this segment, and what do you know about the two new segments? They have to be congruent to each other, and we could use that. Either way, we're going to come up with angle, side, angle, whichever one we use, and we're going to have that extra step in there that we have to do something with, either the supplementary angles or angle addition postulate. So which one do you want to try?
The two,
The
the outside one.
just the two smaller triangles?
Yeah.
All right. So we'll do that. So we've already thought it through. I'm not going to go through and write everything out here. We have a pair of angles. We have a pair of sides. We need this other pair of angles, right? And what do we say about those two angles? We can use that supplementary theorem to say that they're congruent. Once we know that those two triangles are congruent, what do we know about these two sides? They have to be congruent because of CP/CTC. I know this isn't the way I really want you to do it. I'd rather you think it through a little more than we just did. But what's our first statement going to be?
Given E equals K.
Angle E is congruent to angle K. How do we know that? Oops, that's a 1, not a 2. It's given. That was a pair of angles in our two triangles, right? So I'll put an A out there.
And DGH
is congruent to DHG.
How'd you know that?
Given.
That was given to us also. Now here's where you gotta be careful. Can I put an A out here beside that? Those weren't angles in the two triangles that we're trying to prove, right? We're trying to prove this small outside triangle congruent to that small outside triangle. And what you don't want to do is you don't want to go to the other given next, because then you're going to forget all about this and what you need to do with that. Knowing that these two angles right here are congruent, we now need to say that this angle is what to this angle? Supplementary, and this angle is supplementary to that one. Somebody name this angle that I'm got this arrow pointing at right here. DGE. So I'm going to say angle DGH is supplementary to angle DGE. Thing, right? DGH, yeah, DGE. And I'm going to put this in one step. What's the other two angles that I have to say are supplementary? Angle DHG, supplementary to, what's the angle it's got to be supplementary to? This one has to be supplementary to which angle? DHK. Anybody got a reason for that? How come those are supplementary? How come these two angles are supplementary? Say what you're thinking, because it's right. How'd you know that? You guys told me. How'd you know those two? You went too far. They're a linear pair. They form a line, right? And the actual thing is going to be if two angles are linear pair, then supplementary. So if two angles form a linear pair, then they're supplementary. And if you wrote something like, if two angles form a line, they are supplementary, I would accept that also. Just anything to tell me. We don't want to put 180 in there because do we know that those angles add up to 180? No, they didn't tell us all that. Now, if these two are congruent, and they're supplementary to these two, what do we know about these other two angles then? They're congruent. So angle DGE has to be congruent to angle DHK. And our reason, if we were to look up that theorem, I think it had a shortened form. It had a real abbreviated form. I don't know if I can remember it or not. If angles supplement to congruent angles, then congruent. I think that's what it says. So angles are supplementary to congruent angles, then they are congruent. And those are actually a pair of angles in our two triangles. Now where do we go?
Well, that's an angle, so then we go to the other given.
Now we go back to the other given, EG. So look, clear down here in step 5, we're still using what? Given information. Sometimes that's the way it works out. Oh no. It's going the other way. You flipped it back that time on me instead of going forward. That confused the heck out of me.
An anagram is a word that has been changed.
Keep going, Josh.
You change the original letters around to spell a different word. It's a taco cat.
No, that's
that's backwards.
Oh my
goodness, right? No.
So it's an anagram is like when you take
No.
an anagram is when you have the same letters for two different words.
This one's like William Shakespeare
Not-
to be turned into I am a weakish speller.
Right. Not something that's,
Psychotherapist.
not something upside down. I swear I don't think there's
No,
any.
there's a name for words like that.
No, there's
Like Taco Cal, you can.
No, that's backwards.
I don't
That's
understand.
bad.
No, there's a word.
And he's saying like, look at it upside down, I
Forms
don't
another
think
word.
there's.
Well, not all letters.
Yeah, it's like-
Yeah, they're not all reflected, they don't all have that property.
No, like, I don't know, they're weird looking letters and then you flip it upside down.
Oh, I know what you're
It's
talking
like,
about.
yeah,
Gollum
it's-
spells wow.
Yeah, it's like that, but sometimes.
Okay, so let's hurry up and get this done, then you can look it up. How do we know that EG was congruent to segment KH? It was given to us. Was that a pair of sides in our two triangles? It was, wasn't it?
I don't even know anymore, to be honest.
So now, and again, I can't look at this picture that way, it's driving me nuts. I know that I wanted to split off the two outside triangles. I knew that this angle was congruent to this angle. We proved that this angle was congruent to this angle. And we now said that those two segments are congruent. Do we have enough to say the two triangles are congruent?
Yeah.
Yeah, by which postulator theorem? Angle, side, angle. Now here's where we gotta make sure we match up the triangles. Somebody, go ahead.
EG
DEG.
and DKA.
So D in the first triangle matches up to what in the other triangle? D. E matches up to K. And G matches up to H. And how'd you know that? Angle, side, angle. Remember, with the two triangles, the only reason it can ever be is one of those four things. Well, that wasn't what we were trying to prove. But as soon as we prove those two triangles are congruent, what can you tell me about those two sides right there?
They're congruent by CP.
They're congruent by CPCTC. So segment ED, not EG, is congruent to segment KH. And our reason is corresponding parts of congruent triangles must be congruent. A lot of this stuff you use the assignments on page 211, 10, 14, 15, 17, 18. I think the first 5 there are 2-column proofs. And then 25 through 28 is just matching up triangles and giving reasons for those triangles being congruent. Please make sure on the first 5, at least draw the picture on your paper before you start writing your 2-column proofs so you can mark stuff. And next class, map test. And make sure that you get the E-Day stuff into me in the next week or so. I'll put it off till the last minute. And if you grab this worksheet up here, you want to do some extra credit work, you can grab that and that'll be counted as extra.